The central theme of what we're here for is so-called smart cities. So it seems reasonable to start with the idea of trying to pinpoint what do we mean by a smart city. So this is my view of a smart city coming from engineering. In engineering, particularly in systems and control, we like to talk about closed-loop systems. So you start with collecting data, which we know we can do now because of the evolution of sensor networks. These are networks of small or big devices that you can spread all over the place and collect all sorts of useful information, from cameras to sensing the traffic that goes through various streets, sensing the health of the infrastructure, bridges, and so on. The next step would be to turn this data into useful information. That's not trivial, by the way. Data is one thing, information is another thing. But there is this whole big data revolution that's going on right now. So we have the techniques and the methodologies to do that. And then, continuing on to close the loop, using this information, you want to make intelligent decisions and actuate various systems, which will, in turn, produce more data, and the loop goes on and on. In order for this to work, you have to operate in an environment where you have to guarantee such important constraints like privacy, security, energy management, safety. All these are important considerations. And if you do your job right, then you will have the various smart services that emerge. Now, you hear about the word smart attached to smartphones, smart grids, smart cities, and so on. You probably experience the same smart fatigue that I experience all the time. Everything seems to be smart. So it seems reasonable to try to understand a little bit more what we mean about smart. Certainly, one of the things that is required for you to be smart in this environment is to collect data. However, as I try to point out here, collecting data is not smart by itself. It is a necessary condition to being smart. What you really need is you need to be able to use all the data to collect in order to make the good decisions that make you smart. So this is where closing the loop comes into play. When I talk about our smart parking approach, I will return to this point. I don't want to spend too much time on this, but for those of you who like definitions and so on, these are various definitions of a smart city that you can find in the open literature. This, for example, is the industry perspective. This is a definition from Hitachi's website. This is a definition that comes from economics. I did not attribute this quote to anybody in particular, but this is from the economics literature. This is from the government and policy literature. And this, which I highlighted, is the technologist definition. So here, the important thing is using information and communication technologies, supporting innovation. These are the words that make me feel good. Technology, information, innovation. So I don't want to spend time on this, but people are struggling with the effort to define what a smart city is. Already I told you in the previous slide how I see the concept of a smart city. It's something where you collect a lot of data, absolutely, but then you use the data for something meaningful and useful, not just for the sake of having data. In fact, I will argue that data by itself can be harmful, and I'll give you an example. So what I'm going to do in the next 10 minutes or so is simply quickly go through a bunch of stuff that we have done here, mostly working with the city of Boston. For example, we have developed a smart parking system, which is actually deployed in a garage where I park every day, which is down, I think, that way, towards the BU Bridge. And we have an app which allows you to use it. And in fact, there is an annual IBM IEEE Smarter Planet Challenge competition, so we won a 2011 prize of that. I'll tell you a little bit more about that because it has some interesting implications. The advent of electric vehicles makes it very interesting to study problems of how do you actually route now vehicles from origin to destination, given that now you have to take into account the recharging effect. So if this car is not an electric vehicle, this is clearly the quickest way to get to the destination. But not if you're an electric vehicle and you might need to be recharged here. So these are interesting considerations that we study. Traffic control, there is a big revolution going on, a really game-changing revolution, that of so-called connected vehicles, or if you prefer, connected and automated vehicles, CAVs. that is really a game changer because, as I will argue, we don't know how to control traffic systems, transportation systems very well for some pretty obvious reasons to anybody who knows elementary game theory. But I think this is changing the game. Traffic lights. Why is it that traffic lights seem to be so stubbornly static so that I am stuck in a red light with nothing happening in cross streets and I waste my time there, not to mention burning fuel? So I'll talk a little bit about that. We were working on this. And this is a really cool application which came out of the city of Boston. It's called Street Bump. This is also an app that you can download. It's free. And we won the 2014 prize for this. This is a way in which you can detect bumps in the street just leaving your iPhone next to you or your dashboard in your car, because your iPhone has GPS and an accelerometer which detects vibrations. So what we do is we collect massive data, talk about big data, of these vibrations, and then we process them in smart ways, really smart ways. And so we can provide feedback then to the city, and we say, look, out of all these bumps around, there are some which are really bad, and others which are not really bumps that you can do anything about. For example, speed bumps. Those are natural bumps. So we provide kind of a prioritized list to the Department of Public Works so they can go and fix the right potholes as quickly as possible. So let me spend a few minutes on smart parking because it captures this idea of what is smart. First of all, the motivation is very clear from the literature. Turns out that in any big city, about 1/3 of vehicles are just going around looking for parking. And it takes about 8 minutes to find parking. So the current state of the art is based on guidance. This is information alone, which tells you where there is a parking spot. So maybe you'll go and you'll find it, or you're too late, somebody else has grabbed it. It may not be very good for you, for your purposes. And there is the issue of also processing information while you drive, so it's not very safe. But it's worse. From the point of view of the city, you have an imbalanced utilization of your parking spaces because people don't know where all the good spaces are, and this is the worst. Actually, the information, if we all want to go 2 blocks down, say when there's a Red Sox game, and everybody wants to go there and there's 2 parking spots available, we all converge there. 2 people get the parking spots, and the other people just drive around in frustration, creating more congestion. So in fact, this is the example I was mentioning, having just data could actually be bad, not good, because it creates phenomena like this. So in a nutshell, we have turned the process of searching for parking to a process of competing for parking, which is really unnecessary given the technology we have. The smart parking system that we have developed works like this. You're in this car, and you simply say, I want to go there. So what the system does is it finds you the best parking spot, best in terms of least distance from your destination and least cost. And it reserves a parking spot for you. So I'm not going to go into details of how we implement this, but we have the technology to know where available parking spaces are, and we also have the technology to implement this reservation scheme. I'm not going to get into that. If you're interested, I can talk to you offline. We have implemented this, but let me return to this theme of collecting data is not smart by itself, because if you just tell me that there is this parking spot there and then you leave me on my own to get there, by the time I get there, somebody else may have taken it, or it's actually not the best spot for me. However, processing data and closing the loop to tell me that this is the best spot for you and you got it, go there, taking action based on data, that is smart. Okay, this is really the premise here in a lot of this work that we do. Anyway, as I said, we have implemented it. This, in fact, is the garage where we are working with. If you can see these little white spots, these are sensors which detect and they tell you that there's no car here, but there is a car there. If you look at these green and red squares, this is a camera approach that we took. So red means that there is a car there, green means there's no car there. That's how we know where the parking spots are. And actually, this has been going on for a number of years, and it has attracted a lot of interest in local TV and newspapers and so on, because it really captures the imagination of the average citizen who says, really, I can do this? I can actually find parking spaces and I don't have to drive around and all that. But really my purpose of going through this particular application is precisely that smart is not just telling you where parking spaces are. It's doing something useful with it. Street bump is, as I said, an interesting application of technology that is free. So this is the reason why I usually talk about this, is because an example of where you don't need infrastructure. One of the difficult things that we face when we talk to cities, for example, and we give them good ideas like smart parking, they say, this is all great, but what's the investment cost? So the answer here is zero. It's already there. Somebody has produced something called an iPhone that has an accelerometer and a GPS, which can detect the vibrations as you drive and tells you where they are. The only cost is to develop this app, which was developed not by us actually, but by a small company working with the city of Boston. But I could get a graduate student to develop this in about 3 days. And that's it. The rest is the smarts of, again, taking the data and doing something useful to close the loop by telling the DPW where do you go to fix the really important potholes. The way this works is through the same type of technology that we use in cybersecurity, where you want to distinguish normal behavior from abnormal behavior, normal internet traffic from abnormal internet traffic. So here you have normal bumps and abnormal bumps, and we manage to differentiate this. Now, here is another interesting point about how do we bring these technologies into cities and work with the people that are out there, okay? The people, the humans, which is something that we engineers, by the way, tend to ignore, okay? Sadly so, but it's true. And this is one of the lessons, by the way, that I've learned as an engineer working with the city of Boston. You can't ignore the people, okay? So here, the idea is to draw this distinction. There are other projects in Boston where what they do is they take a van and they load it up with very sophisticated, expensive sensors, and this van roams around Boston trying to detect potholes. So it's only one van. It costs about $100,000 by the time you put all the equipment, okay? And obviously it's not going to find everything. We do it for free with lots of data, perhaps not the same accuracy as the expensive hardware on this van, but not only we're able to do this, but there are some interesting side benefits which involve people. And here they are. No infrastructure is needed, just your iPhone. Minimal cost. I don't have to have expensive hardware other than develop this app. Much better coverage, because if you give this app for free and you engage the citizens to drive around and collect this data, then obviously you get a lot more data. The cycle of repairs goes down. And perhaps more important than everything, you engage people. You make them excited about this. Give them the app for free. And you say, look, if you participate in this, the pothole that's in your neighborhood may get fixed tomorrow as opposed to next year, which in Boston happens a lot, by the way. We know that from personal experience. So I think this is important, and this is where economics and social sciences come in. How do we build in incentives, economic mechanisms to get this technology to be used? And that's really the lesson that I'm learning from this. Traffic light control, here's the problem. I'm not going to go into details, but this is, again, from my personal experience. This is Comm Ave, and this is the BU Bridge. And this is typically me, except I don't drive this fancy car, leaving around 7 o'clock in the evening. So the traffic is not that bad. My office is about there. And here's what happens to me. Stop, 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 because I need to go all the way down to get to the pipe. And it takes me maybe 3 minutes. There's hardly any traffic here, and certainly no traffic in the cross street. What I should be doing is this. Because all these traffic lights are nothing but nodes in a network, they could be talking to each other and saying, hey, there's him and a few other cars coming. If there's no cross traffic, just keep the light green or turn it green. It's very simple. If you do that, and of course a lot of other details, you have this automatic adaptation of green and red light cycles. You can predict and alleviate congestion, not just locally, but you can study how this propagates into an entire network. You avoid congestion, and as two side effects, you lower pollution and the waste of fuel, because you don't have to stop. So these are all benefits of these types of technologies. finally, on the traffic control, this is my little simulation of a Google map of the BU Bridge. This is an example of incredibly bad design. This is ComAv, okay? So this is, question would be down there. So if you come from this direction, which I do every day, you're not allowed to make a left turn on ComAv. So this whole stretch here is underutilized. What you need to do is you need to come this way and go there. Now, the traffic that comes this way comes from here, from there, and can go straight across the bridge, to the left, or to the right. You cannot imagine what happens right here when people get stuck, while there may be zero traffic this way because you're not allowed to make a left turn. So actually, for the last few months, we're studying this intersection, and I'll show you what happens if you use connected vehicles technology and avoid all the traffic. Now, let me just answer the question of why is it so hard to control transportation systems. The answer is twofold. Number one, we just don't have enough controls. And the only controls we have is traffic lights, green and red cycles, some tolls, some speed fines. That's just not a lot. So we have no chance to use feedback. As a control person, feedback is everything. It's all over the place, in your cars, in your phones, in your computers. It's an incredibly powerful concept that we can't use it. Worse, elementary game theory 101, tells you that when you don't know what other drivers are doing, what their behavior is, you make bad decisions, which lead to what we call selfish optimism. We each try to optimize our own little world. I want to go there, and I'm going to cross lanes and do whatever I can and change my speed. But if all the cars now become nodes in a network and we control it, then that goes away. Right? Everything is optimized to the social optimum. In fact, using data from the city of Boston, we have just recently completed a study to measure what we call the price of anarchy. Price of anarchy is the gap, the physical gap between this and that. So what we have found, with real data now, in the whole network based in Massachusetts, is that the price of anarchy can be as high as 50% and as small as 0. But in many cases, it's up to 50%. What does that mean in plain words? That with connected vehicles, or even with better traffic light control, I can lower your frustration level by about 50%, your commuting time by about 50%. Right? So at least we can quantify now this, because otherwise I can stand here and say, oh, I've got this great technology, and I can make traffic better. Nobody would believe me. But if I can show you in black and white how this price of anarchy is measured, it becomes more believable. So if we can avoid traffic lights, that would be great. And this, in fact, is that same BU bridge with traffic lights and without. So here you see every once in a while, for example, here that the queue builds up because there was a red light, and there will be a queue building up here because there's a red light. Here there's no traffic lights. If you look carefully, you see traffic going through. We don't have it very highly utilized, but there you go. Just everything is timed perfectly. Nobody ever has to stop. And you just go through just in time here as well. And you can see this is more impressive when we actually load up the system more. So this works. Not only does it work, but it's a win-win situation. What we have found is that you can lower fuel consumption, because you never stop, by about 40%, and you can lower your congestion level by also about 40%. So it's very, no-brainer. So, lastly, what do we do here? We do many projects. We're working with the city of Boston, but also with federal agencies. In this particular case, we have a project that we call SCOPE, which is funded by the National Science Foundation, and some corporate partners that fund the underlying cloud technology, and the state of Massachusetts, which is also funding this. And SCOPE stands for Smart City Cloud-Based Open Platform and Ecosystem. Our concept is simply that if you have cloud software, which is proprietary, it's very difficult to extract data that an innovator needs. If you make it open, and what we do is we combine our academic research experience with public agencies that give us the data, with corporate partners that provide the solutions, we make it easy for hackers, for researchers, for other companies to get data, for example, that the city of Boston would love nothing more than just offload onto us. And if we do that, then the data becomes accessible to everybody, and we can develop more of these smart services that I just told you a little bit about. So I'll just stop here, and thank you very much.